Hello, my name is Justin Kalap, and I'll be presenting V2V and its vulnerabilities. This is for my EEL 4789 Ethical Hacking class at FIU with Dr. Faisal Kaleem. It was a fun class. This video is for educational purposes only. Please do not use any of this knowledge for harmful purposes. V2V isn't around yet anyways, so good luck. So what is it? V2V networking stands for vehicle-to-vehicle networking. And what it is cars can communicate to each other, their location, their speed, steering angle, for safety purposes, so they don't hit each other. It's being pushed by the Department of Transportation and the NHTSA. They have a lot of grants right now for research and things like that to figure out all the little algorithms so that way cars can safely drive on the road. So why do you care? Why is V2V important to us? Well, for one, we'll have safer roads, we'll have self-driving cars eventually, and we'll have a more connected world because cars will be able to talk to each other. Imagine seeing somebody on the road and you're like, hey, what's up? And then to sum it up, I think that this quote is very fitting for the point in history for V2V. Decades now, it's likely we'll look back at this time period as one in which the historical arc of transportation safety considerably changed for the better. Similar to the introduction of standards for seatbelts, airbags, and electronic stability control technology, the National Highway and Transportation Safety Administration. And also I found these two pictures right here, before V2V and after V2V. I think it's pretty interesting. So how it works. It's ad hoc networks, where networks are created instantaneously as you're driving down the road with other partners. It's a trust relationship with the ad hoc network. Cars will know where each other are by communicating their GPS location and other things of that nature. A very good example of how the systems will work is similar to that like Mercedes. How Mercedes has their ultrasonic sensors on the car that make sure you can't hit anybody or run anything over or hit a car in front of you and things like that. After going to the NHTSA website and looking at the kits that they have for research, there's two main components to this. The part that talks to other cars and the part that talks to the drivers. And then there's the other part which collects all the data. But it seems though that the first step in trying to implement V2V is to get a response time quick enough to be safe for drivers so there's no immediate harm. And that's where the ASD comes in. That will alert a driver as to if there's anything coming up next to them or anything like that. And then the VAD is what's going to be communicating GPS to other cars and things like that. And if there's a VAD on two cars that detect that they're going to collide, then there's a warning sent to both cars, and then the vehicles are alerted. This is similar to current methods where a light flashes on a car when somebody's in your turning or blind spot. So I see similarities with the auto industry and similar technologies, but nothing as standardized as this by the government. So some applications of V2V networking. One, you have efficient city driving. There won't be any like ripples in traffic when you're driving. Like this picture right here explains it perfectly. Say for instance you have a driver in the front, slam on his brakes, and then you have a person all the way in the back, their response is delayed. And this ripple travels through traffic, decreasing the efficiency and ultimately making us angry as we get to work. But as we see here with V2V, somebody with a VAD communicating to another car with a VAD, they'll be able to detect and anticipate and brake ahead of time. So that way the cars in the middle right here, they don't even matter and aren't even felt by the cars behind them. So that's one really good thing with V2Vs. You get really good efficient city driving. No braking and accelerating, braking and accelerating. Next you have collision avoidance. As I mentioned earlier with Mercedes and their techniques for collision avoidance, it's a little different because you actually have two cars communicating their positional data to each other, whereas Mercedes is just a standalone system that detects objects around it. Kind of another out there application of this is the autopilot system. If you have a network of cars being able to communicate to each other, and they know their final location and destination, and on top of that, the street data, who's to say that a car can't control itself to its final destination? So right now, there's actually applications being done right now in research. So that's one thing. And then another thing is to report data in real time, like traffic, weather, road conditions, even bad drivers. I found a research paper about that. So how would V2V work with your car's systems? In order for it to work, you would have to have the brakes, steering, and acceleration known and controllable by a computer that's communicating with all the other cars around itself. Because that computer would have to be able to take in the data, that other acceleration, steering, and brake data, and calculate both of those cars' positions and figure out what each one needs to be doing. At the same time, you would have to know the GPS data, so that way the cars would maintain their position on the road relative to each other. Another interesting thing is vehicle to infrastructure networking, where, say for instance, you were parked in a parking lot and your car unknowingly is communicating to the network at the mall, enabling hackers to get into your car and things like that. In this picture is a diagram showing all the different computer controlled systems in your car that V2V would be able to control and take charge of for safety purposes, and in turn be able to communicate that data through its wireless network and put it out there for other people to get. After searching the internet for instances where people were able to hack into other people's cars, I found this device, which was a homemade device for relatively cheap. And what it does is it RFID hacks into any car. It's an RFID cracker that cracks into cars like Toyota, Lexus, Porsche, cars right now that have a wireless RFID card identification tag in order to start the car. So you can just walk up to any car you want, press a button, and it cracks the RFID code and you're good to go. Start the car and have some fun. So what are the possible dangers of V2V networking? Well, for one, someone can GPS spoof a location onto your device. I'll explain that further. I'll explain each one of these later on. There'll be immediate threats to personal safety, like you hurt real bad, real quick. And then a lesser risk is data. Your data is at risk, but data is replaceable. Personal safety is not. GPS spoofing is a really scary possibility with V2V networking. To me, it has the possibility to be the most dangerous because, for one, you can be driven to any location that you don't know if you're distracted behind the wheel, playing games on your Game Boy or reading a book. And also, it's the same exact technique that was used on that $40 million yacht that we all read about a couple months ago. It's very real possibilities. And then on the lighter side, you can get GPS spoofed to try and do that Fiat commercial where you drive across the ocean from Italy. Or say for instance your car tries to drive itself into the mall. You know, those are really real things that could happen if we don't come up with techniques to avoid this. There are immediate risks when implementing V2V networking. For instance, a fake car can be set up by spoofing that information to a hacked car, causing the hacked vehicle to react in a way that causes harm to passengers, like immediate braking or turning sharply, things like that. That'll also cause harm on the highway, traffic, things like that. Hackers can do very crazy things with this. And as stated earlier, the opportunity for physical harm is very real, and data is always replaceable. So the fact that there's an immediate risk for physical harm, that hackers can hurt people with this type of technology needs to be looked into, and in my opinion, very secure methods need to be put in place in order before these systems can be implemented. Data that's at risk within a vehicle-to-vehicle network is limited to the way in which that data on that car is connected to the other cars around it. Say for instance a vehicle with vehicle to infrastructure networking through a SIM card that uses cell phone towers. That SIM card will have user information that might be valuable for targeted malware that might have targeted ads on the highway, just like how we get targeted ads now. Also, user data that's stored on the car in terms of financial systems like paying tolls with vehicle to vehicle networking. As I keep stating and reiterating over and over and over again, data is replaceable. The fact that the immediate personal risk of this technology having very harmful effects on people when hackers can get a hold of it is very, very dangerous and needs to be looked into very deeply. So how can we mitigate these security threats within a V2V network? For one, we can limit the communicated data and connectivity of the systems within both of the cars. We can only communicate the positional data for alerting drivers of a situation. That's one way. So that way the computers wouldn't even have control or access to the steering or braking or GPS. It would just be strictly for alerting. Or another level above that, which exposes more risk, is to just have it be responsible for braking. Say for instance, somebody's on their phone texting, avoid a rear-end collision. But systems like that already exist on high-end model cars on the market in standalone systems. There's also the GPS encryption technique, where a car is always moving, so the encryption is always changing. So the change in the coordinates between the cars is constant and predictable, making it impossible for two cars to exist within a certain radius. So if you see one car's location but are getting two signals that are interpreted as one car on top of the other driving down the road, then you know something weird is going on and not to trust that signal coming from that car. To sum everything up, vehicle-to-vehicle networking is just as revolutionary for the transportation industry as airbags and stability control were. But it has its downside. It has the immediate risks to personal safety that aren't involved with other hacking techniques. So to solve that, limiting the communication of the data that's between cars is vital to the success of this system. Thank you for watching my presentation on vehicle-to-vehicle networking.